Good morning, good afternoon, good evening. Thank you for joining me. This is Ms. Hernandez. We are continuing our video lectures on chemistry. Today we're doing 5.13. It's known as orbitals, and of course, all this information comes from your CK12 packet. Okay, just because it's in a PowerPoint does not mean that it's not what you have in your packet. It is based off of what is there. Okay, I am working again with fifth period class. Welcome, guys. And fifth period, let me know if you have any questions. All right. So, who is going to help me with the introduction? It says, how is it that so many planes are able to fly in the sky above us without running into each other? Okay. And not too long ago, there was an accident where two planes did collide, but it doesn't happen very often. Okay. Normally, before you even take off, your flight path gets registered or sent to the FFA, and they approve or or say you can't fly because or they make you change it. Right? They tell you exactly what to do to avoid a collision with another airplane. But I need somebody to help me with the reading. Who's helping? Alexia, Oscar, Melissa, who? Come on, guys. I need somebody to help me. Oscar, are you there? No, I cannot hear you. I can't hear anybody. No, I can't hear you. Oh my God. What's going on? Can you guys hear her? Can you guys hear her? Oscar? Did you just, hello, Oscar? Okay, my Google, let me restart. Okay, I'm gonna have to restart this. Okay, so you guys can hear. All right, hold on. Let me just hold on. Sometimes it does this. Okay, so I'm just gonna refresh, guys. It might kick me out, but I'm gonna come right back in. Having some technical difficulties here. Hello? Can you guys hear me? Oscar, can somebody come off mute?
Sí, sí la escucho.
Oh, there you go. I hear you guys now. Okay. Perfect. I don't know what happened there. All right, yeah, Alexia, thank you so much for volunteering. Go ahead.
The flight path of a commercial airliner is carefully regulated by the Federal Aviation Administration. Each airplane must maintain a distance of 5 miles from another plane flying at the same altitude and 2,000 feet above and below another aircraft. 1,000 feet if the altitude is less than 29,000 feet. So each aircraft only has certain positions and it is allowed to maintain while it flies. As we explore quantum mechanics, we see that electrons have similar restrictions on their locations.
All right, can you guys, if you're on Google Meet, can you see my screen now? If you're on Google Meet, can you see the screen? I totally forgot that I was not sharing. Okay, thank you. All right. So thank you, Alexia. So what Alexia read is that, if there is an airplane close by, you have to have 5 miles in between you. If you are flying over, in the same area, you have to have that 2,000 feet either above or below another airplane. If you're below 29,000, you have that separation of only 1,000. But the FFA, if it does its job correctly, is able to observe where a commercial airplane is flying so that it can direct other airplanes out of its way. Okay. And this mostly happens with me Of course, I've experienced it going to Vegas. Every couple years when I go to Vegas, um, you'll see a bunch of airplanes waiting to land, and that's because there's a lot of people who are trying to get into Vegas. So you'll see a bunch of airplanes flying in the air with you. And that's mostly where I've experienced it. I don't know if you guys have ever experienced that, going to another large city. Another one that I think I remember is when I went to Las Vegas. I mean, not Las Vegas, New York. That's a big hub. There's always airplanes coming into New York. And I remember we were delayed for a little while because we're waiting, for our turn to happen. But the reason why it's coming up, the reason why it's part of our introduction is because electrons also have restricted airspace around the nucleus, right? It has its own area where it can orbit and move around as much as it needs to, okay? And that orbit, that specific orbit, will be different for every pair of electrons that an atom has, okay? Every one orbital can hold only 2 electrons, right? So always remember that. Each orbital will have 2 electrons in each. And you're going to see that there's going to be multiple versions of the same orbital, mostly because there's a lot of electrons, and those electrons are going to have are going to need their own space. So here we have we're talking we can apply so we're talking about orbitals, right? And we can apply our knowledge of quantum numbers to describe the arrangement of electrons for a given atom. That is the definition of electron configuration. Electron configuration describes how electrons are arranged in these different orbitals, okay? Think of it as a map. Like if you open up a map of the state of Texas, it's going to tell you where all the different cities are and how to get to them. Electron configuration is a map for an atom to see where and what type of orbitals that atom has and how many orbitals, okay? So just think of it as a giant map, okay, for where to find electrons. We look at the 4 quantum numbers for a given electron and then assign that electron to a specific orbital. And this is the periodic table that I usually use to teach electron configuration to my students. You have 4 different colors for each of the 4 orbitals that we're going to be talking about today. You have what's known as your s orbital, your d orbital, your p orbital as in Peter, and your f orbital as in Frank. Okay? And if you look, all the s orbitals can only hold 2 electrons. If you look here, the d orbital can only hold 10 electrons. The p orbital, all of them hold 6 electrons, and the f orbital holds 14 electrons. So we're going to talk about that right now. But before we continue, what is the definition? What is electron configuration? What is electron configuration? Okay. And you could compare it to what we compared it to, but just give me your understanding of what electron configuration is. Okay, Gabby and Irvin got here. Let me change that before I forget. All right, I got you, Irvin and Gabby. And you should be typing right now. You should be typing your response. What do you remember that we said is electron configuration? And use the words, what does configuration mean? What does electron mean? And just tell me what you remember. What is electron configuration? What is electron configuration? Okay. Well, we know it has to do with electrons, but what about these electrons for these atoms? Give you some time to think. 1 out of 6 students has started answering. What about the rest of you guys? What do you remember electron configuration is? What do we compare it to? Remember, I said Austin, Dallas. Where can I find all that information from? All right. Nobody else started writing. So let's see. It tells us the electrons of an atom or a molecule, right? It describes how these electrons are arranged and in what orbitals and what energy levels. Okay, so it tells us a lot of things. It tells us where electrons is at. It tells us what orbital it's at, what energy level it's at. There's a lot of information that electron configuration gives us. It even tells us the valence electrons. Okay, it provides a lot of very useful information. So here's your first orbital that we're going to be talking about. It's known as an s orbital, and the main most important thing that you have to remember is that it's spherical in shape. It's going to be round, right? And you have your s orbital for energy level 1, 2, and 3. And what do you notice about these orbitals? They're all the same shape, but what's the difference? There is something different about 1s, 2s, and 3s. What do you notice that's happening to these orbitals?
They're getting bigger.
They're getting bigger, right? For the 1s, you can say it's like the size of a golf ball. For the 2s, you can say it's the size of a baseball. And the 3s is more like a softball, very large, right? Definitely a lot larger. You can even say it looks like a basketball or even a soccer ball, right? But either way, we know we have a golf ball sized, we have a baseball sized, and then we have a much larger size. And if you go to energy level 4, 5, and 6, it's probably going to get bigger and bigger and bigger. Very good. But before that, there is only one orbital there's only one version of this s orbital. So remember, each orbital holds 2 electrons. So every single s orbital can only hold 2. That's it. The other orbitals can hold more because they have different versions of themselves. And you're going to see right now. All right, guys, everybody, draw an s orbital. Draw it out. And you don't have to draw the black lines, right? I don't want you to draw the X, Y, and the Z plane. You do not have to draw the black lines. The only thing I want to see is your s orbital. What does your s orbital look like? Everybody, please start drawing. What does an s orbital look like? 1 person out of 7 is drawing. And it's probably Alexia or Oscar. So what about the rest of you guys? Draw. I want to see your version. All right, I got 2 people. Oh, it's Oscar. Sorry, Oscar. It's you. You ready, Oscar, to show us? Very good, right? You got 3 different versions of the s orbital. You got the small one in the energy level 1. You got a medium-sized one in energy level 2. And then you have a very big one for energy level 3. And it's supposed to be more round than this. But I know it's hard to draw when you have a mouse and not not your finger or whatever it is. Like for me, I can just touch screened it, but no. A ver. Very, very good. A small one, a medium, and a large one. Excellent. Good job, guys. Perfect. It looks like a ball, right? It looks like a sphere. Very round. All right. Now we're going to talk about p orbitals. And you can see there's 3 versions of your p orbital. There's the Z, there's the X, and there's the Y orbital, p orbital. Okay? Each of these can hold 2 electrons. So there's 2 here, 2 here, and 2 here. How many total electrons for all 3 of those orbitals? Okay? How many for all 3 of those orbitals? Si tienes 2 en el primero, 2 en el segundo, 2 en el tercero, ¿cuántos? How many?
6.
6. There are 6 total electrons in that p orbital, and you can see it here. You can see all of them end at 6. You can have less than 6, but you can never have more than 6. Okay? And I always say it kind of looks like a balloon that got twisted in the middle. Some people say it looks like a figure 8. Some people say it looks like a dumbbell. The ones that you pick up. I don't know. You guys tell me. What do you think it looks like? All right. So total of there's 3 different versions. There's the PX, the PY, and the PZ. Each of them holds 2. So 2, 4, 6, just like Irvin said. Very good, Irvin. Now, Irvin, draw a p orbital. If you are in Pear Deck, I want you to draw what you remember a p orbital looks like. And you don't have to draw the lines. I just want the shape. I just want the shape. Only 2 students, 3 students are drawing. Oscar, Irvin, and Alexia. Where are the rest of my students? Why are you not drawing? Mario, where are you drawing, Mario? Hania, Arlette, are you drawing? Yoslin, Efrain, America, Gabby. All right. Oscar says he's done. Let's see. Remember, they're connected, guys. They are connected. Very good. This one's good. This one's a good one. Very, very good. Very good. It kind of looks like a figure 8, right? Very good. Excellent job, guys. It looks like some people say it even looks like a peanut. Maybe. All right, now we're talking about the d orbital. And if I were to describe these d orbitals, I would say that they look like a 4-leaf clover. Looks like a butterfly. This one looks like a butterfly to me. This one and this one. This one looks like a 4-leaf clover. 4-leaf clover. 4-leaf clover. 4-leaf clover. And then look at the last one. It's very, very special in what it looks like. I always like to say it looks like a p orbital with a hula hoop. Right? It's like a peanut with a hula hoop around it. Okay? These are all the d orbitals that you have. And if you look, and there's 2 electrons in the first one, 2 electrons in the second one, 2 electrons in the third, 2 electrons in the fourth, and then 2 electrons in the fifth. How many total electrons can fit in a d orbital? If each one holds 2. How many total electrons for a d orbital? So if you got 2 here, Oscar, in this one, you got 2 here, 2 here, 2 here, 2 here. They total 6? No. They total what, Irvin?
10.
10. 10. All 5 of these can hold up to 10 electrons. I can hold 2 here, 2 here, 2 here, 2 here, 2 here, for a total of 10 electrons. Okay?
6, miss, because you're like the higher number, like the higher one is 6 nomás.
Mm-hmm. All right, very good. Now we have what's known as the F orbital. The F orbital, I kind of think it looks like M&Ms kind of like standing up. Well, at least these do. They look like M&Ms. But over here, these look like decorations, right? At a party, balloon decorations at a party. That's what it looks like to me. And then this one looks like a p orbital with 2 hula hoops around it. A p orbital with 2 hula hoops. And don't worry, I'm not going to ask you to draw it. I'm not going to ask you to draw it. But I am going to ask you, and Oscar, here's the time to redeem yourself, Oscar. If I got 2 electrons here, 2 here, 2 in this one, 2 in this one, this one, this one, and this one, how many total electrons for all 7 of these F orbitals? How many electrons? If you got 2 floating around here, 2 floating around here, 2 floating here, 2 floating here, 2 floating here, 2 floating here, and this one, how many total? Aquí tienes 1, 2, 3, 4, 5, 6. There you go. Damn, Irvin, you're fired. Good job. Yes, total of 14. Okay, he has a total of 14. Why? Because there's 1, 2, 3, 4, 5, 6, 7. 7 times 2, 14 electrons in those orbitals. Okay. Here's a table that tells you for energy level 1, 2, 3, and 4. You remember yesterday, energy level 1 can hold 2, energy level 2, 8, energy level 3, 18, energy level 4, 32. And this is how they're arranged. If you're talking about the energy level 1, it's only going to have the s orbital that holds 2. In energy level 2, you're going to have your s orbital that can hold 2, 3 p orbitals that can hold 6. And then for energy level 3, you got 1 s orbital, that's 2, 3 p orbitals, that's 6, 5 d orbitals, that's 10, and you have your total of 18 electrons. In the 4th energy level, you're going to have all 4 of them. You're going to have an S, a P, a D, and an F. So that means 1s, 3p, 5d orbitals, 7f orbitals. And if you add up all these numbers, they should give you that 32 electrons that are in there. Okay. Uh-oh. You got a question before we go to the video. We're almost done, guys. We're almost done. What is the total number of electrons in a d orbital? What is the total number of electrons in a d orbital? Anybody remember? Remember, those d orbitals are the 4-leaf clover ones. There's how many orbitals? There's 5. If each of them holds 2, how many electrons?
10.
Yes, sir. Very, very good, sir. There's 10 in there. Excellent job, guys. All right, let's watch this video. And it's got some weird music, but it's really cool because it shows all those orbitals and how they overlap. And I'm going to pause it so that I can make it bigger. And then I'm going to restart it one more time. It's going to start with, it's only going to talk about the first 3. It's going to show you the s orbital, the d orbitals, and the p orbitals. Okay. After that, we don't talk about f. Okay. This one's only going to show SPD. And I know it's weird music. So here's your s orbital. Looks like a baseball. So here you have your px, your py, and your pz. In red is the px, in orange is the py, and z is in yellow. Okay, so here's 1 orbital, 2 orbitals, 3 orbitals. So here's your first d orbital.
Orbitals.
The second one. Now's your third. There they are. Here's your fourth. And then you have your fifth orbital. And now they're going to overlap all of them. They're going to show all of them together. First, they're going to put the S, then the P, then the D. Okay, and look at the size of them and how they differ. So you got that S orbital, P orbitals. Look at the difference in size in the P orbital in comparison to those D orbitals. A lot bigger than the P orbitals. A lot bigger. And there it is. That is how these orbitals overlap. Okay. Thank you for paying attention. That was excellent. So let's finish up the pair deck. In summary, there are 4 different classes of electron orbitals: the S, the P, the D, and the F. These orbitals are determined by the value of the angular momentum quantum number, L, which we don't really go a lot into it in regular chemistry. That's more for pre-AP and AP. Review questions. What is an electron configuration? Number 2, how many electrons are in energy level 1 orbital? Number 3, what is the total number of electrons in a p orbital? And number 4, how many electrons does it take to completely fill a d orbital? Students, thank you for paying attention.